So, Kostya, the
All
floor is yours.
right, thank you. So I'm doing a guest lecture today on authentication and authorization, which frankly is, of course, a topic that is way larger than one lecture. And I'm going to be starting from the very beginning. So hopefully you will also guide me on where you are with your authentication, authorization, understanding, etc. So we have a Q&A section at the end that will hopefully help us build on top of it. But for now, let's start with let's say with a fixed schedule. So who am I? Why am I even qualified to talk about authentication authorization on this less than sunny morning? So I've been working in IT for more than 15 years. Most of it was hands-on. A lot of it was developer, architect. A lot of it was in enterprises. And in fact, for the last 6 years or so, I was working in a company called World, which is a huge publisher and a content and expert solution provider. Um, And right now, I am actually I am a director for AI platform at Wolfsklur's Legal and Regulatory, which is like 20 or so AI projects running at the same time. But this is a management title now. I keep alternating between the um, management and hands-on titles. Used to be principal developer. In any way, my work is shared across discussing technical and organizational stuff. And now, other things is that I created the API v3 at TimePad, which is known to people from Russia. I used to be an architect in Badoo Bumble dating service that is, I think, a little bit out of fashion these days, but used to be all the craze when I was working there. Yeah, uh, or you can see in more details in my LinkedIn. But basically, a lot of my work was also related to authentication authorization. And in fact, a lot of architecture work especially in enterprises, is extremely tied to architecture. Is extremely tied to these concepts. Now, in my case, I will not talk a lot about enterprise stuff because that will require you to actually that will require to build on top of a lot. So I will focus on the basics. And then we will see if you have Q&As for me, or I will just do a short whiteboard session in the end about like the complications that are arising at large companies trying to implement identity solutions. Now, what is exactly the plan? So I will talk first about using the stuff without auth, which is basically when do you need and not need the auth. Then I will talk about authentication and authorization. They are always shortened to AuthN because of authentication AuthN and authorization AuthZ. Now, I always use the British spelling in my work, but it's AuthZ from the American spelling, so it can also be authorization with Z. Doesn't matter. Talk about tokens. You might have heard about JSON Web Tokens or JWTs. You might have heard about Auth. And we talk about some complications in the end. Now, if you haven't heard about any of those, you're in luck because I'm going to talk about it from the get-go and from the sort of the very beginnings. But also, if you feel like you are not following anymore, please raise your hand, do a shout out because I will happily also go into more details. Now, authentication, right? You have seen this page. You more or less have the idea. This is the you have some clients, some backend, and it's talking some database. Now, who is in fact using the client? Well, it's our guy, the user. We call him Bob. Now, backend by default does not know that the user is Bob. Does not know who Bob is. Just serves you the content. Now, an example of that would be the site of the Constructor University, right? So somebody walks in with the Chrome browser, says, "Give me the page." the browser gives them the page, it works. We don't care. We don't need authentication. That is more or less what you guys have done on the lecture 3, right? You create an API, you call it via Postman. Whoever can call it via Postman can upload the gets. Now, you still might want to think here about complications. So you still might want to think, so for example, when you run an API locally, then only from local hosts so people running on the same machine can access it, right? That would be network controls. Can be more complicated than that, but that's the gist of it. You want to think about rate limits, right? So any websites, you heard probably the term DDoS, meaning that somebody is using the site too much, so it just goes completely down, right? So you want the rate limits, even if you don't know who the user is. You want the encryption, right? And this is actually something that I will mention that I will not mention going forward, right? But all the communications at all times, always, I assume they are using the encrypted connection. From the user perspective, that just means that you are using HTTPS, but there's more to it than that, but it goes beyond the scope of this lecture. Just make sure there's always encryption in transit. Yeah, and many other things that you need to care about, but maybe you don't need to care about authentication. So start there. Ask yourself, do I actually care who the user is? Do I want to know if it's Bob or if it's Alice or if it's some other folk or can I just serve the page? Oftentimes you can just serve the page or the content or what have you. Now, what if we do care? Now, why would we care? So the backend wants to know who the user is. Well, simple idea. Maybe you have an LMS, right? You actually do want to show the correct data relevant to a particular user in the LMS. Now, how would you do that? Well, everybody knows that. You show a username and password page, and then the user sends their username and password back. So this is the user, the sort of visible to the user part, right? Is this the screen, the username, the password. And in fact, funny thing is, the password is actually literally usually sent as is. That is where, again, I remind you, you need to be completely encrypted. So you need to be encrypted when it's going sent this way, because you need to know, is this the right form? Is this actually sending the username and password to the right place? And it needs to be encrypted, of course, on the way out so that nobody can wiretap and hear what the username and the password is.
I have a question.
Go ahead.
So, like you say, this communication needs to be encrypted, and from the client, just means using HTTPS, right?
Yeah. Yeah.
And if someone is using HTTP, not HTTPS, then like, what can go wrong? Like,
right. So the typical example that they give is, suppose that this guy Bob, right, is actually sitting in a cafe, right? So he's drinking a cup of coffee and he's using a public Wi-Fi, right? Now the public Wi-Fi actually connects to a router, someone in the basement of the coffee house, right? And now it might be the case that this Wi-Fi point is hacked or is malicious, right? So maybe he thinks he connects to the Wi-Fi of the coffee house, but he connects to the Wi-Fi of like some nefarious attacker, right, called Alice. So the point is, if this is encrypted, right, then whatever communication you're having between Bob and the backend, even though it's going via Alice's router, right? If this is encrypted, then Alice in theory cannot do anything to it, right? And there is like a bunch of properties that you want good encryption to have, right? So you want not only that LS cannot read your password, right? She cannot modify the form that you've been presented, right? That's why I'm saying you get to encrypt on both sides. So the password, so she cannot also make it seem like something is working when something is not working. So she can only like break the internet completely, but not specific parts of it. Now there are many sort of exceptions, etc., and details to this, but the base idea is that if it's decrypted, then whoever owns the router in the coffee shop can actually read your stuff, and if it's encrypted, then they cannot. This is also incidentally why they sometimes advise you to use VPNs on public networks, right? Is because the VPN is going to provide a different encryption, right? So then you have an encrypted connection to the VPN, and then only within the VPN do you have a decrypted connection to the backend. But that is sort of goes beyond the scope. The idea, the base idea is must be encrypted because otherwise whoever owns the router can read your password if they want to.
Okay, makes sense. Thanks.
Now, so what happens after the password is sent to the backend? This is where we actually invoke the database, right? So the website actually checks if if Bob exists, right? And if this is a valid password. This is usually, by the way, this is the point is that we do not store the password in the database, but usually we store the hash of the password, which is again goes beyond the scope of this presentation, which is something to keep in mind. In general, do not use this presentation to implement stuff. It's everything is simplified across the board, but it will give you the idea about how things work, and then if you try to implement stuff, actually look things up directly. Now, the point is, we check the password here. The database says everything is okay, and then the website gives you a cookie back. We'll talk about cookies in a bit, but that's just something that is happening here. So just to recap so far. So this is the strategy, the default strategy there is to authenticate the user. Somebody types their login and password. We call those credentials. This is like one of the options of how credentials can look like is login and password. Can be something else. Browser sends the credentials to the backend, and then the backend is now know that the browser is operated by Bob because he validated the credentials. Now, let's talk about cookies. Cookies is already a slightly complicated subject. So the main thing to know is that HTTP or HTTPS is stateless. What that means is that every request you send to your backend using your client needs to start from scratch. It used to be that it was actually every request is a separate connection. Now the connection is actually kept oftentimes, but still the paradigm stands. So every time you talk to a backend, it is actually a separate connection that is completely unrelated to any previous ones. Now, if you are unrelated, how do you actually keep the state? And then cookie is part of the answer. So it is sort of a reminder. The server says, hey, please send me this with next request, and then it uses this to identify you. So it's what it says here. Now, what the cookie actually contains, that we will actually talk about it also in the future. But incidentally, that's why you are seeing the cookie banners, right? In Europe, right? Why are they called the cookie banners? Is because that is the way that they track you. So how do all these tracking things do that? Is they give you a cookie, and then you need to send the cookie back according to the specification of the HTTP protocol. Now, this, to be clear, for actually tracking, that's also like only one of like tens of options of how you can be tracked, right? But cookies is the most basic one of them, so that's why it's called a cookie banner, and that's why they sort of roll with that name. This is where.
I have a
Go
question
ahead.
about cookies.
Go ahead.
Yeah. So sometimes the website is asking me about cookies even if I'm not logged in. Like usually they ask me about cookies even if I'm not
Yeah.
logged in.
Yeah.
So like
Yeah.
you
It's
said that cookie is sent when I log in, but it can actually be
fair.
used if
Fair.
I'm not able.
Fair enough. It's again, it's only like one of the cases. In practice, what happens usually is that you log into the site and it immediately gives you a cookie, even without logging you in, right? Why does it do that? Because, for example, for statistical purposes, it wants to know if you have been on the website before. So even though it doesn't know who you exactly are, it's like it just wants to say, oh, here's your unique identity. Now hold on to it, and I will actually count it. And now this is exactly what EU legislation sort of is against. They are saying, hey, it makes sense for you to save the cookie when I'm logged in, but it does not make sense for you to just send cookies to me so that I can track you, right? So it's your problem that you want to know if the user is visiting for the first time or for the 10th time. We don't want you actually tracking this. So this is the sort of idea where now you need to give consent, and of course you need to do it in the most obnoxious way possible, right? But that is the original idea. This is a way for the site to remember you, right? And this can be used for any purpose whatsoever. Another example is, for example, if you set the language. In some cases, the language that you set can be also set in a cookie. And then again, the site maybe does not care who you are, but it remembers that you speak German. Now, I wanted to give a
Sorry, I have
small.
a
Go
question
ahead.
as
Yeah,
well.
go ahead. Go ahead.
So you said it could be used for statistical purposes,
Yeah.
but if the user is not logged in, we send the cookie. How do we remember that this cookie corresponds to this user in the future? We don't store it in database, right?
We sort of do actually. So let's park this question because I'm going to do a small thing about actually storing the cookie, and that will help us frame the answer to your question better. So let me just remind me when we go to this to the part where I have Redis on the slide.
Okay.
But I will probably remember myself. For now, I wanted to actually do a short demo. But for this, I need to actually be able to switch screens. Let me see. Do you see a browser?
No.
Oh, yes. Now, yes. We see localhost.
Perfect. So basically, what you can do in the browser is you can open the developer console, and the developer console will show you what is actually happening when you're operating the website. So, for example, and this is the network tab. Actually, I use it all the time for my own programs and actually even for somebody else's programs, because oftentimes when the website tells you, oh, something went wrong, you can actually debug them without actually having the source code or anything, because this shows all the communication between your browser and the backend, right? So, how does it look like? Yeah, so you have this is the local host. We made a request. Let me close this guy here. Cannot close this guy.
And this is the server
I lost the technology, but
you wrote yourself, right?
Sorry?
You open it on localhost, so this is like the server that you wrote yourself.
Yeah, I vibe coded an app just to be able to demo some stuff. But this is how this allows me to have something that is extremely simple, right? So what is happening here is whenever I load this website, right, then it sends this request. This is the localhost request. And well, this is unhelpful. So what it does is it sends some request headers, and it receives some response headers and the actual response. Now, the response is just the code of this page. The headers are what's going to be interesting. Now, let's try to sign in. So again, it loads the login page, same idea, some request headers, some response, this page, right? So let's say we log in as Bob. And that sends the login request. Now, the login request is where the interesting stuff happens. So firstly, we are actually sending the data with the username and password, like I showed. And like you see, this is actually not encrypted in any way, shape, or form, right? It's only encrypted on the backend side. The way it would get encrypted is if you used HTTPS, right? Now I don't use HTTPS because I run this on localhost. For localhost, that is sort of an exception, but it's still not secure. I actually sometimes run HTTPS also on localhost just for consistency. But the idea is the same, right? So this is just your password. Sometimes, very, very rarely, they use some protocols that do not actually show the password to the backend, but this is usually considered unnecessary. Now, the interesting part here is the response headers. So one of the header that the website sent me as a response is the session header. So this is a set cookie header with this session cookie. So what that actually does is whenever I send a login and password, it tells me, dear browser, right? This is Edge in this case. Please remember that you have a cookie called session with this value. This cookie is HTTP only, which means that the JavaScript cannot see it. That goes beyond the lecture as well. And please keep this for an hour. And there's some other security stuff. Now, from the point where this gets set, it is now the responsibility of the browser to remember this piece of data. So you can actually see here in the cookies that I have associated localhost this session, blah, right? So now whenever I go anywhere on this website, right? So for example, I open the localhost again. It actually sends in the request headers, it sets the cookie that, oh, I know that this is my session ID. And this is how the website actually knows that this is Bob. Now, in this case, I actually encoded the fact that this is Bob in the session ID, right? But yeah, anyway, we'll talk about this a bit further. But the idea is exactly that. So now every time I go to this website, it is the browser that remembers this item, and then it's the job of the backend to actually know what to do with it. Now, when I log out, that's a sort of a funny story, is it sets a cookie to an empty value, and it says, well, it expires right now. So this is sort of a double way to say, please delete this cookie, right? And now if I go to this website, it actually no longer sets the cookie, and it no longer knows that I'm signed in. Let me go back to any questions about the demo? Otherwise, I go back to the presentation.
Maybe you will cover that later, but like, what's the difference between cookie and JWT token, and which one?
Yeah, definitely later.
Okay, perfect.
Well, hopefully, it will be a little bit clearer. Now, okay, so let's go back to the picture, right? Now, important thing to note, this is the same picture as before. Important thing to note at this point is that this process is called authentication with the N. So this is the process of proving who the user is. And in this case, we do it by login and password. Does not have to be by login and password. But most importantly is that this is just us knowing that this is Bob. Now, a couple of words about passwords. Passwords kind of suck. So people reuse the passwords all the time. So they have the same passwords across different websites. People will gladly input their passwords where they're not supposed to. Your website can just be brute forced. right? So just try 20,000 million passwords until something succeeds. By the way, this is usually done the reverse way. So I don't know, it's like the way you imagine people brute force the passwords is that they send like a million, they say, oh, for this user, let me send a million different passwords. What they actually usually do when they don't care is they have some basic passwords and they try a million different users until they find one that actually has this basic password. So that is actually the reason why you don't want to have a basic password. Anyway, so from the implementation side, you need to absolutely have rate limiting, meaning that you can only try the passwords X times per hour or something, and you want to ban the people who are doing this way too much. Now, also, so this actually is a must. The should part, so what you really should be doing, but you will not be fired if you don't, is doing extra stuff. So one of them is an extra factor. Now, what is actually a factor? A factor is way how you can check that the user is Bob. So beyond the password, it can be, for example, this like 6-digit numbers, or it can be an SMS, or it can be something completely different, right? And usually this is where the acronym MFA comes into play. MFA is multi-factor authentication, so any authentication where you use more than just one factor. And one factor is usually password, and more factors are usually some sort of a token. But it can go way beyond that. Now, I'm not going to go deep into this part. This is, again, not slightly out of scope, but I just wanted to mention it. One thing I also wanted to mention is all of these fancy words. So FIDO or web authentication or passkeys, they broadly refer, they are not the same, but they broadly refer to the same idea. The idea is we can authenticate users by something that is different than username and password. The way it gets implemented these days and the way they sell it is they say, hey, you can log into this website using your Touch ID or your Face ID. This is enabled by these technologies. They are fundamentally better because they tie to specific websites. So you cannot actually fish this out of the user. They also have downsides, but again, beyond the scope of this lecture. As a user, make sure that you always use password managers. Just save the password in your browser. If you don't have a password manager, humans are not good systems for keeping passwords, so just don't. Anyway, that was just a sideline about passwords. Now let's go back to no, actually, let's not go back. The other sideline is about identity. So the identity is an important concept, so I wanted to highlight this. So we have a difference between the actual user named Bob and his or her identity. Now, identity is something that is a term that is used a lot in this sort of authentication authorization discussions, right? What that really means is what we know about that particular user in our system. So, for example, if we don't know the user's gender or the user's role or the user's title or something, right, then they are not part of the identity for the purpose of this website, right? But the user, of course, still has these properties. The identity is exactly the subset that we know about them. Yeah, so usually it's something like an email and some password hash and maybe some other stuff like roles, etc. So to sum up, authentication proves that the subject is a fancy way to say user or something like a user, is who they say they are. We use a password or some other credentials to actually validate that this is the case. We can remember that using a cookie. We can remember this using other methods that we will sort of touch upon in the future. And it matches the subject to the identity. That's authentication. Questions so far? All right. We have until 12:30, right?
Yes.
Okay, good. then I am broadly on time. Now, authorization. So why do we even care who the user is the part that is authorization, right? So let's go again to our picture. Let's in fact make it slightly longer. So we have, once the user has the cookie, they want to request something. So let's say they make a request for the courses and they include the cookie, as we've seen in the demo. What happens afterwards? So we do two checks on the backend. Check number one, can this Bob user even access courses? Like, is he the kind of user that would be able to access courses or not? And if we say yes to this question, then we also do number two, which is we check which of the courses Bob has access to. And then once we are successful with both of the checks, that's actually when we return the courses, right? Some sort of protected information. This, in fact, is authorization, which again, in American spelling is shortened to AuthZ. Authorization is once the user is authenticated, we decide, or the subject, subject is probably a better word, but I like user because it's more down to earth. What is it that the subject can do now that we authenticated them? So authentication is the user or a subject authentically who they say they are? And authorization is, are they actually authorized to do a particular action? This always is a little bit of a mix-up, especially for things like interviews. It's always nice to know exactly what those are and which one and which. In practice, of course, they are all very much interrelated, and I just always talk about Auth without the fifth letter because everything is sort of connected. But this is usually the separation. Now, some of the typical authorization approaches are role-based access control. This is where we are looking into what are the role of this user, right? So in our example of an LMS, the role would be that, oh, I'm a student, right? But the role can be also, oh, this is an admin, this is an editor, this is a viewer. This is context dependent and depends on your application. This is the basic one that people usually start with. And again, if your use case fits into it, then you absolutely should start with it and have it. The other one is attribute-based access control. So this is where we are gathering everything that is interesting about this particular request for a privileged action. And we try to make a decision based on that one. So we say, so who is the subject? What is the object? So in this case, the subject is Bob and the object is course of system design. What is the action, which in this case is probably view? And what is the environment, right? So like, oh, is it on prod? Is it on stage? Is it, which tenant it is, etc. But there are many other approaches. But these are the two ones that you should sort of know, especially RBAC is an acronym that you will meet in the industry a lot. So you got to know this. But in general, again, this is the important part. You just build whatever it is that fits your use case. So you need to also step back and think, okay, so what do I actually need to check to authorize or not authorize the subject to do this or that action?
I have a question.
Go ahead.
I've heard a lot about ACL access control lists.
Yeah.
It is kind of who can do what, and this is like implementation for role-based access control, right?
So it could be anything because it's sort of orthogonal to this, right? So so if you think about it from the perspective of evaluating the access, right? Then you say like, how do I evaluate the access, right? So you evaluate the access based on, for example, is the user an admin or not, or is the user an owner of this object or not, etc. Right? And now an access control list is something that you typically attach to an object.
Okay.
and you say, okay, this object can be accessed to like this list of students. And you use that ACL to evaluate the ABAC when you want to decide whether or not this user is has access to this object. So like one of the examples, and I don't know if actually if IAM AWS IAM is an example of an ACL or not, but the idea here, right, is that you have some sort of a policy, right, that says, oh, because of this, and this policy, you can have access to that, right? And this policy can have all sort of shapes. And an ACL is one of the shape of a policy that you can build to sort of evaluate the access control for your authorization scenario.
So
that is more or less how I understand the terminology anyway.
Okay, so it's like these are two different approaches, and ACL access control list is just an implementation of how you would do this.
Yeah.
Okay.
So it's on sort of a different architectural consideration levels here, right? So if you're looking at if you're looking from like the system design point of view, right, then you talk about things like ABAC or RBAC, right? And if you think about, oh, now I need to see how do I design the ABAC, and it's like, oh, well, I build a policy that's like slightly like an IAM policy, or I build an access control list, right? And usually, by the way, you build all of them, right? So usually you build a role, you build ACLs, you build policy engine, that sort of stuff. But again, same as with any architectural decisions, start small and then see what sort of things you actually encounter.
Okay, yeah, thanks.
Now, the core idea now is fully complete. So we start with an identity. What do we know about the subject? We authenticate the subject to this identity. We authorize the subject to make an action. So this is the takeaway that you really need to have from the first half of this lecture. And these are the terms I would say you need to operate with. Now let's talk a little bit about the implementation. So this is where we talk about tokens, the tasty stuff. That's weird. I say tokens are tasty stuff. Obviously, the cookies are tasty stuff. Well, anyway, now the typical definition of a token from dictionaries: token is an object of value, which is a very funny play in words, because an object of value means that you put a value into something. So it's not a valuable object, but something that you decide is valuable. So, but that is also in general sense, right? So if you have like a token amulet or something, that is also valid. Now, in the context of authentication, that is usually a secret string. Now, what does it mean, a secret string? It's a string that you usually want to keep hidden from anyone except for the party that you intended for. And then what kind of string it can be? So the two ones we're going to look into is an opaque string, which means that it's a string that means nothing. And it's just a way to have a secret value. So like something random usually. Or a JSON Web Token, which is one example of a non-opaque string, of a non-opaque token. That is quite typical these days. Now this abbreviates to JWT. The spec of JWT actually says that you need to pronounce a jot, but I found out that if you pronounce a jot in the audience that is not already people who have read the RFC, then they have no idea what you're talking about. But you know, it's same as GIF and GIF, right? This is pronounced jot. Do with it what you want. And this is not limited to these two options. These are the two we're going to look into. But in fact, hey, you're in control. Whatever you put in the token, this is what's going to be in the token. Now let's go back to our picture. So as you remember,
May I ask about the jot?
Yeah.
So it's not random because it's not opaque string.
Yeah.
So what is how is it?
We will look into it for sure.
All right.
We're getting there. Actually, let me just drop everything on you. So this is an example of an opaque token. or in this case, actually an opaque cookie. Now, I sort of use interchangeably cookie and token. This is for simplicity of explanation. This is not actually in practice that interchangeable, right? But I will just use the example where you put the token in the cookie. In practice, don't put the token in the cookie, but that's a longer story. So this is an opaque secret. Now, how does it work? So the user sends the login and password, like I said. The database checks if the user is a valid user, and then once it succeeds, the backend generates a random value. This random value is then stored somewhere in a cache. For example, it can be Redis. It can be the operative memory, by the way, of the backend, but that has a lot of downsides in the large-scale deployments. So usually it's something like Redis. And then it sends this random value to the browser. So now the browser has this cookie exactly like we saw in the demo, and then whenever you send a request, you include this random value. Now the browser doesn't care and has no way of knowing what that value is. It's just like, hey, this is something you gave me to remember you by. And then every time you make a request, the backend needs to check with Redis, hey, what does that token mean? And the Redis says, well, it's Bob. Don't you remember you put him like 2 minutes ago? And that is when we can actually check which courses Bob has. So, like I already says, this is an example of an opaque token. So opaque means, from the perspective of this guy, we can do absolutely nothing with this value. Now I remember we had a question parked, but I forgot what the question was. No? Okay, I remember I said that we need to talk about this question later. Later is approximately now, but maybe it's already answered. Let's see. So
the question was about the cookies and how do we remember the cookies for the user, but I think it was already explained.
Yeah.
It's just connected to the session.
Yes. Right. So from the perspective of the browser, the cookies are stored in the browser's own like cookie database, right? And then from the perspective of the backend, the cookies are stored in some sort of cache, right? Now the cache can be because when you say session, right? In fact, what session means is it's essentially an abstraction on top of this cookie. So when, for example, you use PHP and you say, oh, please start a session for this user, what happens under the cover is exactly that. So the PHP generates a random value. It sets this random value as a cookie. It remembers this random value somewhere in its own cache. And then whenever the user brings back the cookie, the cache actually extracts everything that got saved to it that is associated with this random value, right? So this is essentially how to implement a session. So that's just something I wanted to know, because say, oh, well, it's stored in the session. It's not stored in the session. That the storage of the session is this, and is implemented by exactly the cookie. Now, this is the opaque token. Now let's look at the JWT.
So I have I think the original question was something like about we use cookie to track analytics, but how?
Yeah. Oh, yeah. There were two questions, right? So the first one, yes, and the second one, yes. Now the second one is very simple. So if you want to use cookies for tracking, right? You just skip this part. And you immediately set the cookie whenever the user opens your website. So what you remember is not that 1R2N is Bob, right? But you say, oh, this random token just means like a user from the Netherlands or something, right? And then you know already, oh, this guy is from the Netherlands. And then as he walks across your site, he's like, oh, this is the guy from the Netherlands who visited like 4 pages or something like that. And this is how you set this basically profile on a user by using this cookie continuously as the as they use the website, even without authentication, right? Because you just assign a value to this guy, right? And now the guy has a value. This is exactly the sort of like tracking / privacy issue where I don't want the website to remember me theoretically as a privacy conscious user, but the website remembers me anyway, and there's nothing I can do except for turn off the cookies. But if I turn off the cookies, then pretty much nothing ever works, right? So I can no longer log in. I can the website no longer remembers any of my choices, etc. And so the whole point of the cookie law is actually they want to say split this. They want to say, hey, I want the website to remember my choices. I don't want the website to remember me for the purpose of tracking. But nobody actually implements it this way in practice.
I also have a question. Like, can we go back a little bit?
Yeah.
And
Yeah.
you said that when a browser sends a cookie, it says save this cookie for some time. And like,
yes,
if I open a website and I like browse and said, I don't know, like my preferred language or something, and then I close this like browser tab and I open the same website in a year, for example. Will the same cookie will be used most likely or not?
Basically, yes. So the it is the server that sort of here tells you for how long do you keep the cookie. And there is a way to set like a permanent cookie, which is basically just set it to expire in 10,000 years or something like that. Now, I don't remember. I think there was some standardization going on to actually limit how long the permanent cookie are permanent for. But anyway, you can definitely for sure set the cookie for a really long time. Also, you can set the cookie for a really short time. So one of the things you can do is you can set the cookie until the browser closes. So this is one of the explicit things that you can do with this thing. And then whenever the browser closes, you're forgotten, and then the browser is open, then this particular cookie is no longer there. And you can set multiple cookies with multiple expiration dates. There's like tons of you can scope the cookie to a particular path on the website. There's tons of customizations to how you can do that, right? So this is also a fascinating topic of its own. But broadly speaking, yeah, and it is kind of in your control, right? Because remember, the cookie is stored in your browser, right? So you can go ahead and you can delete the cookie for specific browsers, right? And then the website should completely forget you. Now, in practice, there's also like 5-6 other ways to store data in the browser for a particular website. So we need to clean them all. And cookie is just the most basic one and the most typically used one and the simpler one to explain. But this is just something that you can do because, again, the backend only remembers you insofar as it can correlate you with some value. This is also where there is a topic of fingerprinting. So one of the things that they are doing, for example, is that they can run some JavaScript code in the browser that can try and identify you even without a cookie. So even if you deleted the cookie, it will still know, oh, this is a guy who uses that particular version of Chrome on that particular device and this particular resolution. So that is also something that nefarious sites do to when you, for example, don't let them save data about yourself. But that is all goes way beyond the presentation though. Okay, I'll do a third try to go to JWT. So JSON Web Tokens, or JWTs, is a string that looks exactly like that. It is a bunch of characters, then a dot, another bunch of character, and then another dot. So this is a very specific value. In fact, if you see a mix of characters delineated by 2 dots, you can be almost definitely sure that you're looking at a JWT. No other value is exactly like that. Now, what is it exactly that those 3 pieces contain? There is a header. This one explains how everything else is encoded. There is the content, which is the actual thing that we store in the JWT, and there is the signature, which is a way to validate that this JWT is in fact valid. Now, there is a website, JWT.io, that allows you to decrypt a JWT token. So you basically and you can have some fun with it. So when you look at somebody else's websites in the browser and you find a JWT token in the console, then you can copy paste token here, and it will most of the time be able to extract some information from the JWT token. So this is, I think this is base 64 encoding. And what this decodes to is 2 JSONs, and this is the third one is the binary signature. So the first part is this JSON. This usually says like which algorithm is used to sign, and that this is in fact a JWT token. The second part is this JSON, which is I see that the screenshot is a bit screwed. And then the third one is the sub, and the third one is something that you use to check whether in fact all of the claims above are true. So, for example, this can be done by a pre-shared secret, like it's done here. Signature, yeah. Now, let's take a look, especially so the signature goes beyond the scope of this lecture, right? Just, okay, there's cryptography that validates that this is correct. The header is uninteresting. It basically says this is a JWT token signed by this signature. Now the payload is maybe slightly more interested. Now,
sorry, can you please go back?
Yes.
So do I understand correctly that you need to know the secret and insert the secret, and using the secret, this website can actually give you the header and the content?
No, in fact,
No?
that is actually a funny story about the JWT token.
Yeah.
So for most of the cases, I think there are actually two approaches, but the typical approach is that even if you completely don't have the secret, you can still read these parts.
Okay.
What you cannot do without the secret is you cannot say whether this is true or false. So anyone can generate the JWT, right? So I literally generated this. Actually, do I have time? Well, I actually don't have time, but I will do it anyway. So let me open JWT.io, right? So you have, so you can just go ahead and you can create a JWT. So you say, oh, you know what? I am going to say, to just generate the JWT, right? And then this is like a secret string, right? And then let's say you lost the secret string, but you have the token. So you open the thing and you paste the token, and you can see it shows me that it's Konstantin. It shows me that this stuff, but it says, oh, I cannot validate the signature. This is because the secret is incorrect. So yeah. Sorry, I need to drop for 1 minute.
Okay,
sorry.
Okay. As I understand, header is encoded, not encrypted. Payload is encoded, not encrypted. And secret is encrypted. And you can only know if, like, you can try to, like, try different possible secrets, and it will just tell you if it's correct or not. And that's it. That's what I understand.
What's the difference between encoded and encrypted?
Oh yeah, so I sent you in chat that base 64 is my favorite encryption. That's a joke. Base 64 is not encryption. So encoding is like, for example, base 64 is in encoding. Yeah, I will not hijack the screen, but I can give you.
So I can do it. I can do it. Don't worry. So base 64 encoder decoder. So essentially, if you encode, oh, this is decode. Guy, some phrase. So essentially, encoding just means that you switch from one format to the other, right? So do you see the correct screen? Do you see the screen with the base 64 thing?
Yes.
Okay, good. So encoding basically means that this is just a different representation of this, right? So if you see this string, you don't need to know any secrets. You only need to know that this is a base 64 string, right? So it is not encrypted, it is just encoded. Now, if I would encrypt something, then I would say I would get some phrase and, for example, a secret key. And then without the secret key, I would not be able to revert this. But this base 64, it's just a different way of representation. The reason why they went with base 64 for this is because they wanted it to look like a gibberish string while still being decodable. So that's how you see, oh, I can decode this part, and then there is the signature. Now, if I remember correctly, and I haven't interacted with this in a while, I think there are types of JWTs where it is actually encrypted. So then if you drop this JWT here, it will say, oh, I cannot decode it. So it will be able to decode the header because the header says, well, it's an encrypted token, but you will not be able to decode the payload because to decode the payload, you actually need to know the proper string, right? So these are the two different ways how you can approach this. One is that it's encrypted, so you cannot decode it. And the other one is it's just encoded, but signed. So you can read it, but you can only validate it, for example, if you have a secret. Now it all ties together also to like a certificate stuff. So theoretically, it doesn't have to be why a secret that you do it, but that's a sort of a also goes beyond the scope of this beginners lectures. Anyway, going back to the payload. So we have claims. This is, by the way, a new term as well. Claim is basically an I wish I actually had a formal definition in front of me right now. But claim is basically an item of knowledge that you have about the subject, right? So this is a JWT token that has this 4 claims. Now, in this case, what they mean is, and if you look at the JWT usually has this sort of like short names which are really annoying. So sub is the ID of the subject. Well, name is the name, role is the role. These are actually sort of custom, so you can have any sort of claims. So you can have like which dish do they like, right, and then have a value. And then exp is a mandatory one, which is the expiration time. So when does this claim, all of these claims, expire? Now, why? Why do we go through all of this complexity? Here's why. So remember, this is the way how you do it with the cookie. Here is the way how you do it with a JWT. So once you authenticate Bob here, you generate the token that is signed. You say, this is Bob, this token is valid for 1 hour, and you generate a signature on this token. And you don't usually actually set it as a cookie, but bear with me. So you set it as a cookie, and then you get sent it every time that there is that the user requests something. So suddenly you do not need a database here at all. You just check that the JWT has a correct signature. This is the CC part. You extract the claims, and you use these claims to actually give the content to Bob. So this is why you want a non-opaque JWT token. Yes?
That's cool.
Okay. Sorry, it's like because you're on my screen, you look like you have a question, but maybe no. Anyway, so uh, that is especially important when you have a system with like many backends and microservices, etc., right? Then suddenly you can pass this JWT token around without having a shared database of what it means. The downside is that that the user here can actually read this token, like so the decrypt it, and they can even sometimes tinker with it, because this is the funniest thing about JWT tokens. It also goes beyond the scope, but I will roll with it. Is that remember how they have this algorithm here? One of the possible algorithm is no encryption, no signature. So a usual vulnerability is somebody generates a JWT token that says, "Well, my name is this. I will not sign this." And a lot of systems accept this. So you need to be really diligent that you're actually validating the signatures.
I have
All
a
right.
question about the signature.
Yeah.
Is it usually like one secret for the backend, or is it
No, it's usually
for user?
certificates way beyond the scope of this lecture.
Okay.
But yeah,
Okay.
it's asymmetric cryptography.
Okay.
So anyway, a token is a temporary string allowing you to confirm some claims. JWT tokens are self-contained, so all the claims or some of the claims or the important claims are in them. And opaque tokens are just random strings. You need somewhere to place the correlation. Now, in practice, sometimes you can have an opaque token that is only opaque to the user, but there's a JWT inside or something non-opaque. But in the simple term, this is usually how it is. Now I need to really run through a complex topic of OAuth 2.0, which is fun. So let me see. One of the usual examples of Auth0 that is clear to let's say like non-enterprise context is the user that don't want to have a username and password. So we have the user Bob. He only ever remembers his Google password, does not want to create an account on your website, but you want to know that the user is Bob. So what would be the dumb solution to this is you just say, "Hey Bob, please give me your Google username and password." And Bob gives you his Google username and password. You send that to Google, and Google gets really annoyed at you because it thinks that you are running a botnet because you have suddenly a username and password of 500 users. Well, don't do this, obviously. And I think that we are by now educated well enough to say, hey, if it's your Google username and password, always only ever put it in the Google website. But this is also a big downside of the passwords, right? So something like passkeys, you will not be even technically able to input on somebody else's website, but username and password, you can, but don't. So what is the alternative? The alternative is that we actually send the user to Google so that they can authenticate there. They authenticate in Google, and then what? Then we actually do a complex flow that is the Auth flow. Now, and I am simplifying here quite a bit. Don't use this schema to actually implement stuff, but this should be useful enough for you to understand what's going on. So our website redirects you to Google. Google shows you the username and password. You send the username and password to Google, not to LMS. Then once that is done, Google sends you back to the LMS with a code. The browser opens this website with the code. The backend uses this code and it authenticates also separately with Google. So it's like they have some sort of a trust relationship as well. And says, hey, this is the code that a user gave me. Please exchange this for the token. Receives back the token. And this token can, for example, be used as a cookie or as a token now going forward. So whenever the user tries to get the courses, they use this token. And then we use Google to actually now, instead of the Redis, to actually validate who this token bearer is. Now, in fact, it's slightly more complicated than that. In fact, it's in fact way more complicated than that, because at every single step here, things can go wrong. And OAuth spec is basically tries to protect you as much as possible. So whenever things go wrong, you will probably not completely fail at Auth 2, because there is like all of this multi-layer protections built in. But the base flow is like this. This is in fact called an authorization code grant flow. This is the default Auth flow. This is recommended for most use cases. This is the shape in which things should progress. There is a bunch of terminology also associated with Auth. So the user is called a resource owner, with the idea that this is somebody who needs to access a resource, so the owner. The authority giving you the token is called the authorization server. The authority giving you the resource is called the resource server. The token is called an access token. It usually, by the way, comes with a refresh token, but that's beyond the scope. And well, the code is authorization code, like in the grant. So this is the bunch of terminology. So to recap, the client never sees any of the credentials. Instead, the resource owner, also or the user, is going to authenticate against the authorization server. The authorization server returns the authorization code that the client can exchange for an access token. The access token is used to access the protected resources on the resource server. Now, this is a lot, and it only really covers the basics. So I have a second disclaimer slide on this. I said this is very simplified. Please do not implement it as written. I did not discuss any of the deep details, right? So we have the PXE flows, you have the state, you have other flows, right? That usually are not recommended. You have all sort of other protection mechanisms that you must implement. You need to remember to always use HTTPS, like I said, etc., etc. So read the RFCs. Do not use this random presentation or any other random presentation to actually implement secure flows. There is always a current RFC for what are the best practices to implement in Auth 2. The current RFC is 9700. This is released this year, 2025. Please read that. And in fact, if you want to ever get the grip of Auth flows, actually start with the best practices RFC. You start reading, and then pretty much on page 1, you will probably encounter some terms that you don't understand. Then go and research what this term means. Then go back. And then if you are able to read the best practices RFC, understanding everything that it claims, then you are going to be in 0.1% of implementers of Auth. It's as simple as that, really. But it will take a while if you're starting from complete scratch. And that is where I am with my presentation. Slightly ran over the Auth 2 part, and we don't have that much time for questions, but let's see. Do you have any questions on Auth 2 or on anything at all with authentication authorization?
Yeah, maybe a bit philosophical question,
Yep.
but I just wanted to ask you. So what is, in your opinion, the best practice in for user experience, maybe? Like, what is the best practice for logging into somewhere? So there is username and password option.
Yeah.
There is verification code on the email, and some other options.
Yeah.
Which one do you prefer? Which one is the best?
Yeah. So like I said in the beginning, right? My background is in enterprise development, not in big tech. So I don't build that much B2C components where you're actually building something for like random people on the street, like Amazon a shop, right? Or like or like Gmail, right? But I built something that is used for corporate usage. Now, for corporate usage, and I actually forgot to include this term, right? The correct answer is always, always, always SSO, which stands for single sign-on. What that means is when you work in a company, right, you have a company issued credential. Usually it uses Microsoft Entra, previously known as Azure AD, but sometimes can be something like Okta or Google Workspaces. And you want to connect via OAuth to the singular identity that the users have on the enterprise. Now, you, of course, are not asking me about the enterprise. And the answer is I don't know, truly, because when you are talking about B2C, it becomes especially important that you balance the usability with security. So something that is the most secure system of them all is the one that's not plugged in. So you don't want the most secure system of them all. You want the system that is the most usable while still fulfilling your requirements. And in order to know whether a secure system fulfills your requirements or not, this is where there's also another concept that I did not mention because I cannot mention them all, is threat model. I am terrible at writing with my mouse, but what you gonna do? So what a threat model is you sit down and you think about who do you think is going to attack you and how. And then you balance who you think will attack you and how versus what is the most convenient way for your users to authenticate to your website. Now, so the two things that I would recommend you to look into is one is indeed the social auth, right? So login with Google, GitHub, etc., etc. And the other one is look into passkeys. So that is something new that we currently have. And then for the user, it can be as simple as, oh, you log in with your phone, right, with your Face ID or something like that. The downside of that is that if the user loses their phone with the Face ID, then they basically lose this access. So you need to really sit down and think, what is it that goes between your threat model and between the user's usability, right? In enterprise, pretty much always SSO plus OAuth or SSO plus SAML. I don't discriminate. There's a bunch of protocols that are specific to enterprise, completely beyond this topic. And then, but for the B2C, start with the threat model and start with talking to the users. Like, is it convenient to you? Does it make sense? Does it work? Personally, as a password manager user, I really hate the flows with email confirmation because then I need to go way more steps. For password manager, I just click and then you just log in. But I know that typical users quite often lose their passwords and then it's a shit show to restore them. Okay. Any other questions? I'll take one last question if we have any.
If I have a question about our OAuth 2. Can you please go back this slide with
Yes.
Google?
There you go.
Yeah. So you said that in our case, authorization server, in our case, Google, gives the access token, which is like JWT token, as I understand, right?
Typically is, yeah. There's like this complications to it, but typically is a JWT token. Doesn't have to be. All because for all we care, it could be opaque, right? So if you look at this flow, it doesn't matter, right? Because we anyway send the token to the user. There is a thing in OIDC, which is an extension of OAuth. There is a thing called ID token, which is where it gives you like a fat JWT token, like really enormous string that actually encodes everything they know about the user, right? But typically, actually, the recommended flow is still exactly like that. So it's like it gives you a small token, which is opaque or like a short JWT token, and then you exchange a short JWT token for like an enormous ID token that will be the user, right? But yeah,
so
one thing. Good.
My question is, like, I thought that in the first slide we had the Redis. So like by this token, like for example, opaque token, we know that this token is this user and this user has like this role, this permission and stuff. And now when we have a JWT token, like everything, what the role of the user, what permissions they kind of have is encoded in the token. So we don't need to look into the Redis, for example. And in this case, like Google, for example, know that you are, I don't know, a Gmail user or something like this, but Google doesn't know that you are the admin of the course, right?
Right. Yes.
And this information about roles and permissions in terms of our system, we need to store it somewhere else. So
still in the database, right? So I did not draw this, right? But actually, so after we say it's Bob, right? That is where we still do here the whole authorization picture, right? So this is actually the story about this delegated Auth, right? Is that, and that causes, by the way, massive problems in general, right? But the thing about especially in enterprise context, right? But the thing that you need to know is that the authorization is still your responsibility, right? So all we figured out here is that this user has this validated claims that are validated by Google. So Google says, yes, this user is bob@gmail.com. But then it's still up to you to know, oh, what is the authorization for this authentication?
Okay.
So, which is funny because you see this guy is called the authorization server, right?
Yeah.
This is because we are operating on multiple levels of abstractions. So from the point of OAuth, what this authorizes you to do is called this endpoint, right? So you as the LMS is authorized to figure out who this user is, right? But from the point of like this guy, it just authenticated with Google.
Yeah. Okay.
It can get more complicated than that because, for example, maybe when you authenticate with Google, you also say, "Oh, I also authorize the LMS to access my Google Drive," right? And then it's of course a huge mess, even to start thinking about it. That you're authorized to access the Google Drive, and you're authorized to this course, which is like set in different systems, and you need to synchronize all of that somehow, right? But this is about sort of practicalities. Yeah.
Okay. Yeah, got it. Thank you.
All right, folks. I also had a demo of OAuth, actually similar to the cookie demo, but I will not run this because we are wildly out of time. So you'll just have to believe me that OAuth actually works.